Hi everybody, today I will be explaining exception handling and all the related topics to exception handling. So let's first start with our program, which divides a number with another number. It takes the numerator and the denominator and gives the result of division. Now, as we all know, division by 0 is not acceptable. And so when this program runs and a user enters 0 as a denominator, the program would stop executing and would give an exception. Now, what an exception really is? Exception is an error or an event that happens during the execution of the program and disrupts the normal flow of program's instructions. So if an error occurs, the program would stop and it would not continue executing. So in order to keep the program executing, we need to provide exception handling mechanisms, and this is done by providing tag catch blocks, as we will see later. So first, let's see how this program runs and provides errors if we divide a number with 0. So we have a method called quotient, which takes numerator and denominator and returns the result of numerator divided by the denominator. Now in the main, we create a scanner called scanner, and we prompt the user to enter the numerator and we prompt the user to enter a denominator, and then we try to divide the numerator with the denominator and we print the result. So let's run the program and see how the normal flow of the program would execute. So here we are running the program, and let's see. Yeah, please enter an integer numerator. For example, I enter 40, and please enter an integer denominator. I enter 4, and the result is 10. The program has been successfully run since there is no error. Now let's try to run the project by dividing it by 0. So we enter 40 and we enter 0, and it shows us an exception. Now what does this exception say? It says that there is an exception in thread main, which is our main method, and the name of the exception is arithmetic exception, which is part of java.lang package, and the description of the exception is divide by 0. Since we are trying to divide the number by 0, we get this exception, and here it tells us where the exception first occurred. It occurred in the main at line 24, and the cause of the exception was in the quotient method, which is at line 12, which we can see here. Line 24 calls the method quotient, numerator divided by the denominator. This was the initial place where the exception was was created, and then in line 12, which is the actual statement which divides the numerator by the denominator, was where the exception ended up. So as we can see, the program has stopped executing, and we do not want the program to stop executing. We want the user to keep entering the numerator and the denominator until he enters the correct numerator and denominator, and we want the program flow of execution to continue. So how do we do that? We do that through exception handling. Now exception handling has two basic parts: the try block and the catch block. Now the try block is basically a block where you try a piece of code, and if something wrong happens in that block, it throws an object which is caught by the catch block, and the catch block tries to solve the problem. So the same program will now be executed using exception handling. So let's see how that is done. Here we have a class with exception handling. We have the same quotient method that takes the numerator and the denominator. Here we say that this method throws an arithmetic exception, which is all the exceptions in Java end with the word exception. There is arithmetic exception, input mismatch exception, we have array index out of bound exception, we have SQL exceptions. So all of the exceptions end with the word exception, and you need to import the classes that are related to these exceptions. Now, arithmetic exception is basically comes under the package java.lang, and java.lang is implicitly imported into any programs. You do not need to import an arithmetic exception. But however, in this case, we can also enter a numerator or denominator that is not a number. We can enter text, so that would throw an input mismatch exception, and for input mismatch exception you need to import this package in order to run the program successfully. Okay, so we have this method, quotient method, that throws, we are indicating that this program throws an arithmetic exception, so that clients of this method, any method or any class that uses this method, knows that it might throw an arithmetic exception and we need to deal with it in our method. So now we have the main, and we declare a Boolean variable called continue loop, and we set it to true. So it determines if more input is needed or not. As we'll see here, the same set of code that we had in the previous program is repeated here inside the try block. Now this is the try block. It reads two numbers and calculates the quotient. So it prompts the user to enter the first number, prompts the user to enter the denominator, and it calculates the result. But if the result is not calculated successfully, it throws an exception, and this exception is called. Exception is basically an object, and this exception type could be arithmetic exception or input mismatch exception, and it is called by the catch blocks. So here we have basically provided the catch blocks, which is input mismatch exception and the arithmetic exceptions. Inside the catch blocks we have parameters. So in this parameter we define the type of exception. For example, this is the type, input mismatch exception, and with that type we give the object, which is you can name it anything. Sometimes programmers name it as E, but here for clarity we have named it as the same type of the class. One more thing that you need to note is that if your try block throws more than one exception, you cannot separate the exception parameters by commas. You have to declare different catch blocks to catch those different exceptions. So for example, here we have input mismatch exception and arithmetic exception. You cannot say, for example, comma arithmetic exception. That would be an error, like it shows here. It doesn't accept that. Okay. Alright, so now let's talk about the Boolean continue loop. We actually want our program to keep running until the user enters the correct numerator and the denominator, and so we create a variable continue loop which is set to true, and once this program runs successfully until this result is printed, we set continue loop to false, and once it is false, the do while, here we have a do while with continue loop, ends. So we want to keep doing this while continue loop is true. Once it is false, we exit from the program. Okay, so let's try running the program and we'll see in detail how the exception works. So here it prompts us to enter an integer numerator, so let's enter 40, and an integer denominator, so let's enter 3. So that is a normal flow of execution. Now let's try dividing it by 0. For example, we have 80 and we divide it by 0. So again, it shows us that we have an exception in thread main with arithmetic exception. Its description is divided by 0, and it occurred in the main at line 24 again, which is okay. So yeah, and it was caused by the quotient method at line 12, which is this. Okay. So now let's try running it again by passing the method not numbers but text. So for example, we say 40 and we say hi. So it shows as an input mismatch exception since the input that you have provided is not an integer, it is of some other type. It says where it occurred. It occurred at line 22. So let's see, line 22 is actually it's here in okay, so here scanner.next, that is our main this one, denominator scanner.next. This is where the exception occurred, and it says that, yeah, java.utl scanner.nextInt. So this is where the exception has occurred, right? Now, as you can see, the program has stopped executing, which we do not want to stop executing. So we have to provide it with, okay, so now we start playing it and see how it works. So for example, we enter a normal number 50 and 20, it would do it successfully. Now try dividing it by 0. We'll see 50 divided by 0. Okay, so it says 0 is an invalid denominator, please try again. It shows the exception type that occurs and it allows you to enter another integer numerator again. So let's try entering an integer numerator again, but with some other type of data type instead of integers. So for example, we say hi. It says that you have input mismatch exception and you must enter integers, please try again. It gives you this message and it helps you to enter an integer numerator again. So now let's enter integers, and it gives you the result and ends the program successfully. Now let's analyze our try-catch block again. So we have the try block, which takes the integer numerator and passes it to the numerator by scanner.nextInt and takes the denominator by scanner.nextInt, and you have the result which calls the quotient method numerator and passes the numerator and denominator to the quotient method. Now this is the quotient method that takes the numerator and denominator. We indicate that we declare that it throws an arithmetic exception and we return the numerator divided by the denominator. And then we print the result and we set the continuing loop to false if it is successfully printed. But if you have divided it by 0, this program would stop here since an exception is thrown, which would be an arithmetic exception thrown, and the rest of these statements will not execute. The try block, this is called the termination model of exception handling. The rest of the try block would not execute, and the program will just stop here. And when that exception is thrown, it will be called by these catch blocks, and it will match its type. So for example, if you divide by 0 and it reads the first catch block, which type is input mismatch exception, it would skip this catch block and it would read the next catch block, which is arithmetic exception type, and it would print exception, and it would print the object. It would call the toString of arithmetic exception object that we have defined here. And then it would print 0 is an invalid denominator, please try again, just like we saw it here. So it printed exception and it printed the name of that exception, for example, arithmetic exception divided by 0. And it said 0 is an invalid denominator, please try again, right? Okay, so now we see the input mismatch exception. It has a similar way. It says exception input and it takes the object, which is input mismatch exception. It prints a line to discard input so the user can try again. What does this mean? The user entered hi, for example, but we want it to forget that input, and we give another input, which is scanner.nextLine, and then we print you must enter integers, please try again. So after this catch blocks execute, the program doesn't go back to the try block, it just sees the code that is after these catch blocks. So if we didn't have a do while loop, it wouldn't go back and it wouldn't ask the users to enter the numerator and denominator again. It would just end here and stop. But we want the users to enter the numerator and denominator again, which is why we have provided the do while loop. And it says while continue loop, so our continue loop is still true like we said it before, and so it allows the user to enter the numerator and denominator again. And once the numerator and denominator are integers and the quotient is calculated successfully, continue loop would be set to false, and once it is set to false, the while would be false and the program would stop executing. So this is basically how the try catch works and how it handles exceptions in a program. Now let's see how chained exceptions work. Okay, now we have this program right here. Let's just okay, so now let's talk about the finally block. The try catch usually has a finally block included with it. Now basically what a finally block does is to release the resources that were allocated in the try block. So for example, you want to read a file and then an exception occurs, or even if it doesn't occur, the finally block tries to release the resources that are used in the program so that the program runs more efficiently and effectively. So a finally block runs even if there is no exception or if there is an exception. Unlike the catch block only executes if there is an exception in the try block. So this is demonstrated by this program right here. So we have the main, we have try. Inside the main we have try throw exception. It calls a method called throw exception, and by the name you can know what this method does. This method throws an exception, and we catch this exception of the type exception, and the object is called exception, and the type of this object is exception, and we print a message that the exception is handled in main. And next we call a method that is does not throw exception, and from the name you can understand that this method does not throw an exception. So now let's see what throw exception and does not throw exception actually have inside their bodies. So in throw exception we declare that this method throws an exception. So clients of this method, for example the main that is using this method throw exception, knows that this method throws exception of type exception. So we try to throw an exception and catch it. So here we print that we are in method throw exception, and we try to throw new exception. Now basically you would not use this statement throw new exception in your program, but we explicitly use it to see how the flow of exception runs through the program. So basically throw new exception throws an exception object, and then we catch this exception object using this catch block right here by saying exception exception, and then we print a message saying that the exception is handled in method throw exception. And then we attempt to rethrow this exception for further processing. So when we throw this exception, we don't handle it anywhere here again. This goes back to the main, which called this method initially. And then we have the finally block, which executes even if there is no exception, and it prints that the finally executed in throw exception. Now let's see the does not throw exception block. Here we have a statement inside the try block that the method does not throw any exception, and then we have the catch block which takes an exception object and it prints the exception object, but this would not execute because in the try block we have no exception thrown. And then the finally block would execute, of course, because there is whether there is an exception or there is not an exception, the finally block would execute regardless. Okay, so here we print that the finally does not executed in does not throw exception, and then we print a line saying end of method does not throw exception. So here let's run the program and see how it works. So the method first prints method throw exception. Now why does it do that? Because we call the throw exception method in the main, so it goes to the throw exception and it prints method throw exception, and then this method throws an exception, so it goes to the catch block and then it prints exception handled. Okay, method does not throw exception. Okay, and then it says exception handled in method throw exception. Okay, and then it says finally executed in throw exception, because the finally block would execute even if there is no catch, even if there is an exception or there is not an exception. Okay, after that we throw the exception here in the catch, which is caught in the try block here. Yeah, in the try catch of the main, and so we say exception handled in main. Alright, after that we go to the does not throw exception, so then it prints the normal method does not throw exception. It does not throw exception, so we do not print an exception object. Instead we print finally executed in does not throw exception, which is this line of code, and then we print end of method does not throw exception, which is right here. So this gives us an idea of how the exception objects are jumping from one method to another, and how the finally block executes even if there is an exception or there is not any exception. So last but not least, we will have to look at the assertion. So alright, now we will talk about assertions. So exceptions were basically to find out errors that happen in the program and to let the program continue flowing smoothly so that the user does not encounter any disturbances. Even if the user enters any wrong input, the program would respond and tell the user by messages what they have done wrong in the program, and would allow the user to continue entering data so that the data is of the correct type and the correct values, so that it is accepted by the program. But assertions are basically for debugging and for finding logical errors inside our program. So this is not for users, it is actually a debugging tool for programmers. So for example, in this program we have to enter a number between 0 and 10. So we take the number and we check the assert. So assert has expression 1 and expression 2. This is expression 1, which is a Boolean exception. It can be either true or false, that the number can be between 0 or 10, or it cannot. So if it is between 0 to 10, we continue and we print that you entered this number, or else we print bad number and we print the number. So this is basically just for the programmer to know if the program is running successfully, if the inputs are given successfully or not. But if we want to show errors to the end users, we have to use exception handling. So let's see how this program works. We'll run it and let's see. Okay, so we enter a number between 0 and 10. Let's enter 5. So it says that you entered 5. Now let's try to enter some other number, for example 20, which is outside the range of 0 and 10. And it says that you have an exception in thread main. It is an assertion error, bad number 20, and it indicates the line where it occurred. It occurred here, right here. Okay. So this was the concept regarding assertions. Now let's talk a little bit about the exceptions. Okay, so basically we have checked exceptions and we have unchecked exceptions. This diagram shows the exception hierarchy of the exception classes. Now what does this exception hierarchy actually shows is that all of the exceptions are subclasses of the class throwable. Now in the class throwable we have two subclasses. We have the exception subclass and we have the error subclass. The exception subclass again is divided into runtime exceptions and IO exceptions. Now what are runtime and IO exceptions? Basically, runtime exceptions are those that occur due to something that is wrong in your code. Runtime exceptions can be actually corrected by correcting your code. For example, array out of bound index, array index out of bound, or index out of bound exception, or input mismatch exception, null pointer exception, arithmetic exception. All of these kinds of exceptions can be handled or can be prevented by having a good code. For example, null pointer exception occurs if your object has not been initialized and you're trying to use it. So first you can try to check if the object is null or not, and then try to use it, which would prevent this kind of exception. Again, array index out of bound exception, if you know where your index starts and where it ends, this exception would never occur. So this is why runtime exceptions are called unchecked exceptions. Unchecked exceptions means that they are never checked by the compiler and they do not follow the catch or declare rule, as we will mention shortly. Okay, so IO exceptions are exceptions such as during file processing. You have, for example, exceptions that you are not capable of controlling. So these exceptions could be disk IO completions, or network message arrivals, or mouse click and keystrokes that you cannot handle. So these are called unchecked. These are called checked exceptions, where the compiler actually requires a catch or declare requirement. Now the catch or declare requirement basically means that if this exception occurs, then it must be either declared using a throws clause, or it must be caught by the try catch block in the program, or else there will be compilation error. Now error and its subtypes, which is AWT error, thread death, and virtual machine error, are basically exceptions that you cannot handle and they are not under your control. So basically errors are exceptions that you cannot control and you cannot provide any kind of exception handling for them. So they basically represent normal situations that happen in Java virtual machine, and most error happens unfrequently and should not be caught by applications. It is usually not possible for applications to recover from errors. Okay, so this is what we had to talk about the checked and unchecked exceptions. So now we know that runtime exceptions are unchecked exceptions. The compiler doesn't check for these exceptions, but it is good to handle these exceptions either way in the try catch blocks, and we can catch or use the catch or declare requirement for them. The IO exceptions are basically exceptions that require the try catch block and a catch or declare requirement, and the error exceptions are ones that happen infrequently and they are not under the program control. So so it is good to not actually catch those kinds of exceptions. Okay, so we have talked about what an exception is. They can happen due to several reasons. If a user has entered invalid data, a file that needs to be opened and cannot be found, or a network connection has been lost in the middle of communication, or the Java virtual machine has lost out of memory. Some of these exceptions are caused by user errors, others by programmer errors, and others by physical resources that have failed in some manner. We have talked about checked and runtime exceptions and unchecked exceptions. We have talked about the exception hierarchy, that all of the exception objects are subclass of the throwable class. And we have also talked about common types of exceptions that happen, which are out of range arrays and arithmetic overflow exceptions, division by zero, invalid method parameters, or unsuccessful memory allocations. And exception handling is not basically designated to process problems such as disk I/O completions, network messages arrivals, and mouse clicks and keystrokes. We have talked about how exceptions are handled. This is done when an error occurs within a method and the method creates an object and hands it off to the runtime system. The object called an exception object contains information about the error, including its type and the state of the program when the error occurred. Creating an exception object and handing it to the runtime system is called throwing an exception, basically. So after a message throws an exception, the runtime system attempts to find a solution to catch that exception, which is done in the catch block. So we have a stack trace. Basically, these lines of codes are called a stack trace that indicate where the exception has occurred and what its cause basically is, right? And we have different types of exceptions: input mismatch and arithmetic exceptions, which sometimes needs to be imported if they are not implicitly imported by the project. For example, java.lang does not require importing it, but input mismatch exceptions require importing its package for exception handling. And we talked about the termination model of exception handling, which means that if an exception occurs, the program directly exits the try block, and all the local variables that were declared in the try blocks would go out of scope, and it would eventually go to the catch block. And when the catch block terminates, all the local variables would again go out of scope. And so if you need to use those local variables outside the try catch blocks, you wouldn't be able to use them. And even after the try catch block, it doesn't go back to the try block after an exception occurs, and it goes to the catch block. In order to do that, you need to use a do while loop, which is what we used in here. We used a do while loop here, and we set our program to keep reading two numbers and calculate the quotient until the user entered the right values. Okay, and then we talked about the throws clause. The throws clause basically indicates that a method actually throws an exception, so that the clients of that method are aware that this method throws an exception, and they provide the appropriate so even if you use standard methods, you can check the throws clauses, so you can provide appropriate exception handling mechanisms in your program, and you use those standard methods. Also, for assertions, you have preconditions and postconditions. So basically, preconditions are conditions that must be true before a method is executed, and postconditions are conditions that must be true after a method is executed. So for example, if you're using a character at method, which is a string method, you would expect the input to be a integer, which is between the range of that string. So for example, you have string hello and you want to find character at index 2, so it would give you back L, right? So you must make your preconditions and postconditions clear in your method, so clients of your methods know what kind of exceptions they might expect to handle if they do not meet those preconditions and postconditions. So that's all about exception handling, and hope you find my video interesting. And if you have any questions, you can comment below, and thank you for listening.